chemistry lesson, and we're still on stoichiometry, and today we're going to discuss about limiting as well as excess reagent. Limiting as well as what excess reagent. But before we go straight to defining what limiting reagent is and excess reagent is, let's just look at this concept. When we're looking at a chemical reaction, so whenever the chemical reaction is taking place, it's not usually that all the reactants, let's say we have A and B, will equally used up at the end of reaction. Sometimes one reactant might remain while the other one is finished. So that's the whole concept of limiting and excess reagent. You have two reactants, one is completely used up, one is still remaining. So that's the whole concept of limiting as well as excess. Let's try to use the common example. Let's say maybe you are having a project, you want to build a fence. You want to build a fence and you've asked the builder to give you a quotation. Let's say maybe the builder said that for you to build one wall, you need 100 parts. 100 bricks plus 2 bags of cement. So for you to build one wall. So you're on a project of building a fence. But according to the builder, for you to build a one wall for that particular fence, you need 2 bags of cement and 100 bricks. So let's say you have in hand you have 500 bricks, and you have let's say 4 bags of cement. So let's see how many walls are you going to build using what you have. In other words, using what is available there. So you see that if we were to break this, we say I have 100, 100, 100, 100, and 100. So we have bricks, bricks, plus 2 bags. If we were to break this one into two bags and 2 bags again. So you still have one wall and one wall again. So 100 bricks, 2 bags, 1 more. Another 100 bricks and 2 bags, another wall. Meaning to say we've created two walls from what we have. So based on what we have here, you see that the number of bricks, we had 500 and we're remaining with what? We were remaining with 300. 1, 2, 3, 300. While the number of bags of cement, we had 4, and all the 4 have been used up. So if we talk about the limiting and excess reagent, so the one that is is completely used up. So in this case, the number of bags of cement is completely used up. Meaning to say that this one is our limiting reagent. This one, the length of the bricks is our excess reagent because it is still remaining after after the react after we've managed to build the number of after we build the walls of the fence that we want to build. So in this case, this one is our excess. See that the number of bags of cement limits the number of walls to be produced. Meaning to say that the number of bags of cement is the one that is determining the number of walls. So meaning to say that limiting reagent is the one that determines the amount of products in the reaction. So now let's probably define what limiting and excess reagent is. So when we talk about limiting reagent, we're simply talking about a reactant that is completely used up in a chemical reaction. When we talk about an excess reagent, we're talking about a reactant that still remains once the reaction is completed. Okay, Okay, here we have as an example. So let's just read it. Magnesium and oxygen react to form magnesium oxide according to the equation. So Mg plus O2 are producing MgO. So if 6 grams of magnesium and 2 grams of oxygen are variable in the reaction, A, determine the limiting and excess reagent, while B is saying the amount, determine what the amount of what the magnesium oxide produced. So before we go straight to what solving how we can determine how we can come up with what which one is limiting, which one is the excess reagent, there's 2 or 3 rules that we need to know. So when determining what limiting, okay, first if we work out what limiting and excess reagent, we want to determine which one is limiting, which one is excess. First thing we need to do is what balance what the equation, the chemical equation. So sometimes you'll be given the equation, so definitely you just have to balance. But sometimes you just be given the information, and you have to generate the equation in your own. So in that case, once you have generated the equation, you still have to balance. So the second thing you have to do is what to work out what the number of moles. Work out the number of moles. So we'll work out the number of moles using what are the given what are quantities that were given now in our question. So if you are given what are the masses, you try to convert those masses into what number of moles. So then the third, after you've worked out the number of moles of each and every reactant that you have, the next thing is to determine how much each reactant will produce using what the variable or given masses. So after that, after you have determined how much each reactant will produce using the variable or given mass of quantities, you have to name the limiting as well as what the excess reagent. So we're going to follow what are these 4 rules for us to work out on what that are given example. So let's work on that. Given magnesium plus what oxygen to produce what MgO. So what we are required now, the first thing is what is to balance what the equation. As said area, definitely it's what? It's balanced. 2 magnesium, 2 oxygen, 2 oxygen. So our equation is balanced. So our equation is what? Is balanced. So now let's try to work out what are the number of moles of what each and every what reactant that we have. So we have 2 reactants, magnesium and oxygen what gas. So we need to number of moles. I just put N magnesium. So we know that what for us we can have number of moles. The number of moles is equal to mass over molar mass. Molar mass. So where molar mass we can mean Lam if it is an element, RMM if it is what a molecular compound, and RFM for a ionic compound. So in this case, when you talk about magnesium here is existing as what an element. So with that in mind, then it's just a matter of what putting the mass as well as what molar mass. So where are we going to get the mass? So the mass that we're going to use what from the information that we're given. If 6 grams of magnesium and 2 grams of oxygen are variable, meaning to say that what the mass of what magnesium in this case is what 6 grams. So the variable mass is what 6 grams. But that's 6 grams. The molar mass for what magnesium. So we're simply going to use what Lam for what magnesium. So magnesium is equal to what 24 grams per what per mole. So that's the molar mass for magnesium. So we're going to put 24 grams per what per mole. So grams into grams. 6 divided by 24, it's 0.25 moles. So this is the number of moles for what for magnesium. And still we still have to what work out the number of moles of what oxygen. So number of moles of what oxygen. So in this case, please you have to be careful, because most students instead of what let's say be using, because of let's say in this case for magnesium, it was an element. Some, they will forget this one. The oxygen that we have is we have as our reactant is what? It's a molecule. So it's a molecular what? Compound. So number of moles of what? Oxygen molecule. So the given mass is what? 2 grams divided by the molar mass. The molar mass, in this case, we're going to use what? RMM, relative molecular what? Mass. So we know that what? Ram for oxygen, oxygen is equal to what? Is equal to what? 16 grams per what? Per mole. So if we have what? O2, it implies that 2 times what? 16 grams per what? Per mole, which is giving us what? 32 grams per what? Per mole. So here we're going to simply put 32 grams per mole. Let's go on with what? Working out what at the number of moles. So it's 2 divided by 32, which is 0.625 moles. So 0.6. Okay. So sorry. 0.0625 moles. So those are the number of moles of what? Oxygen. Now you see the what in this what balance what chemical equation. This one is just what theoretical. In other words, it tells us what the number of moles that are what. If we are to produce the same magnesium, 2 magnesium oxide, 2 moles of magnesium oxide, we need 1 mole of oxygen molecule as well as what 2 moles of what magnesium element. So meaning to say this one is just what this one is just theoretical. It's theoretical. It is just what tells us whether we like it or not. For us to produce 2 MgO, we need what 1 mole of oxygen and what 2 moles of what magnesium. So, but with what we have, the 6 grams as well as the 2 grams of what oxygen, we see that what 0.25. What we have is what 0.25 what moles Mg plus 0.0625 O2. So that's what we actually have. So we want to know how many moles will be produced by what magnesium as well as what oxygen when they react. So for us to do that, what we're going to do is we're going to do a simple relation. In other words, a relationship where we'll be comparing. Let's say maybe 2 magnesium producing what 2 magnesium oxide. What about 0.25 moles? How much magnesium oxide in terms of moles will be produced? So that's what we're going to do. So we're going to see what. So I'll put if you want to put if 2 Mg, right? If 2 magnesium produces 2. Just put the arrow. If 2 magnesium produces what 2 magnesium oxide. So how much would 0.25 magnesium produce? So we don't know. So if we had to do that, then 0.25 Mg multiplied by 2 MgO divided by 2 Mg. So 2 into 2, 1. Then you have what? 0.25 moles of MgO. So with what we have 0.25 moles of what? Mg. So 0.25 moles of Mg will still produce what? 0.025 moles of magnesium oxide. So now let's look at what? Oxygen. 1 mole of O2 is producing 2 moles Mg, has to be capital M, 2 moles MgO. What about 0.0625? So how much is it going to produce? So we're going to say 0.0625. I'll just put what O2 divided by 1 or 2 multiplied by 2 MgO. So if we were to do the calculations there, so it's just a matter of multiplying this by 2. So oxygen and oxygen, n of 1, it's a fraction, remember. 0.0625 times 2. Let's see what is it going to give us. So it's giving us 0.125 MgO. Now we want to determine which one is the limiting and what excess reagent. We have worked out the number of moles that will be produced by each and every mass that we were given. So now we want to know which one is the limiting and which one is excess reagent. So in this case, the limiting reagent is oxygen. So why are we saying oxygen? So we simply look at the number of moles which in other words, the one which produces the least number of moles. So we see that magnesium produced with what we have, magnesium has produced 0.25 MgO, while oxygen has produced 0.125 MgO. Oxygen molecule is so if the moment we produce 0.125 MgO, oxygen will not be available. Meaning to say that the one that will remain is magnesium oxide. So in that case, our limiting reagent is is oxygen, oxygen gas. So now let's go to the second question, which is saying that work out. In other words, determine the amount of magnesium oxide produced. We want to. So now we want to determine the amount of MgO produced. So 6 grams and equivalent to 0.25 moles of magnesium has produced this one, and the 2 grams, if I talk about the number of moles, 0.0625 moles of oxygen has produced this. So we have said this one is our limiting reagent. So the one that will determine the amount of magnesium oxide produced, it will be oxygen, determining the amount of magnesium oxide, since it is a limiting reagent. So now we know that with 2 grams of oxygen gas, we are going to produce 0.125 magnesium oxide. So meaning to say that we have remember this is number of moles, moles. Number of moles of MgO is equal to 0.125. That's the number of number of moles. So we can still work out the mass, because we know that the number of moles is equal to mass over molar mass. So here is equivalent to mass itself, which we don't know, divided by molar mass. So the molar mass will be magnesium. The number of moles for magnesium oxide in this case is 0.125 moles. We don't know its mass, and the molar mass, simply add the lung for magnesium as well as oxygen. So 24 plus 16 is giving us 40. For us to find the mass, definitely, we simply have to make a mass subject of the formula. So if we want to make a mass subject of the formula, we have a mass is equal to 0.125 moles times 40 grams per mole. So if we have to work on this one, let me just use a calculator. So we have 0.125, 5 grams, 5 grams. Sorry, yeah. So 5 grams. So more and more will cancel. So we have 5 grams. So just to summarize, when 6 grams of Mg reacts with 2 grams of oxygen, we're going to produce 5 grams of MgO. So 5 grams of magnesium oxide will be produced. But for us to know this 5 grams, we have used oxygen, since it is our limiting. In the next class, we will discuss about theoretical as well as percentage yield we'll look at what the actual percentage as well. Sorry. So based on that,